Good morning, ladies and gentlemen. It's a pleasure to see you all here this morning. I'm Jeff Taylor, and I'm going to be guiding you through the Aerospace Startup Showcase here at TechCrunch Disrupt. But before we get going, a program note. The CEO of Scout Space, one of our pitching companies, is terrifically ill and won't be joining us this morning. But I do want to invite you to go take a look at Philip Hover-Smoot and Scout Space and what they're working on with AI and working on the hardest problems in space. They're an excellent company, they're getting excellent traction, and they deserve your attention. So, AI systems are changing how countless software tools and data sets operate. Space is no exception. Our pitching companies will share how they apply AI to this complex, high-consequence domain with its own challenges in security, logistics, and cost. This showcase reveals a story of early-stage innovation and commercial potential. Follow along with us, and for each startup, I want you to develop your own views on how differentiated and sustainable their innovations are, how you assess their commercial prospects, and how capable their founding teams are of driving them forward. We're looking for strong commercial narratives in addition to groundbreaking technological breakthroughs. You see, the government is a critical first funder of early-stage innovation. But between early program dollars and initial venture interest lies a gap where critical technologies and strong teams too often stall. The goal is to understand what's actionable inside of early-stage efforts and bridging this gap ensures that key innovations advance and that US superiority in space remains strong. When America bets early, America wins big. Each startup will now present for 4 minutes to a panel of judges representing venture capital, commercial space, government, and the nation's leading technical authority on space systems. The judges will get 7 minutes of questions for each startup, and they will follow, so I want you to follow along, and then I want you to come back at 11:50 when we'll be making the award as to who won today's pitch-off showcase. So please join me in welcoming to the stage our judging panel who are sharing their time and resources to help us investigate this early-stage landscape. First, welcome to the stage, Tom Swick, Chief Technologist at NASA's Jet Propulsion Lab, with more than 30 years leading advanced space technology development and mission engineering across JPL's research and innovation programs. Tom, welcome. Next, join me in welcoming Dr. Deborah Emmons, who serves as Vice President and Chief Technology Officer at the Aerospace Corporation, where she oversees the company's technology strategy, internal R&D programs, and innovation acceleration initiatives. Thank you for joining, Deborah. We're pleased to have Caitlin Holloway, who is a founding partner at the venture firm 776, where she leads the firm's operation and portfolio outcomes work while backing startups across space tech, climate, AI, and the creator economy. Caitlin, welcome. Thank you for joining us today. And a warm welcome, please, for Mandy Vaughn, founder and CEO of GXO Inc. and an operating partner at Embedded Ventures. She brings deep experience in national security space, launch operations, and commercial government collaborations. Thank you, judges. It's good to have you. So I wanted to start out the session this morning to talk about how do we think about what's going on with AI in space. When we think about the data sets and the tools that are changing the way that we think about space, when we think across exploration, when we think across orbital intelligence, when we think about across infrastructure and more, how is AI affecting the tool sets that we use to maintain American superiority in space? And I'll start with you, Tom. How do you think about that at JPL, and how do you work with some of those concepts?
It's, Jeff, this is an area that obviously we're spending a lot of time on in the AI world. It's blowing up here on Earth, and the way we think about it is how does it apply to the space environment? We're explorers. We're sending our spacecraft to Europa, to Jupiter. We have rovers on Mars. So we have a very limited environment, very constrained. So how do we take these immense systems that are here on Earth, the large language models, the training and so on, and put them onto these systems where you have limited compute, limited power, really extreme environments, but you really, really, really need it for us to really put the humans into the rovers and the spacecraft that we're going to use. So we're really trying to play that game of how do we take this immense technology here, which is changing our world on Earth, and figuring out that little piece of it that we're going to put onto our spacecraft and our rovers.
That's really interesting, and thank you for that, Tom. I know that you've been working hard on several projects having to do with the Mars rover program, and thank you for sharing your intelligence with that. So Deborah, at Aerospace Corporation, you guys are the chief neutral recommender to the US government. How does Aerospace think about AI in space?
Yeah, no, it's really an interesting time now because everything used to be all about the hardware, but now with AI coming on the scene, it's how do we take advantage of this? How do you apply it? And it's really all about the data. So you're seeing really an explosion here of companies. It's pretty exciting. You know, one of the things that we developed with a partnership with SpaceWorks is called the TRL Bootcamp, and it was a way to be able to help companies with their technology to be able to advance that and really get that exposure into the labs. A lot of that, though, was in the physical sciences. We're taking that concept and we're moving it over into the AI. So I really encourage folks to be able to stop by our spoon bender demo, and it's really a way to think about digital warfare and be able to take concepts out and applications of algorithms in a real environment. So it's an AI testing platform, because as you know, Tom just mentioned, environments are constrained and it's really challenging, so you need, before you deploy AI algorithms, make sure that they're really validated and trusted.
The layers of solution sets inherent in the Spoonbender program are really, really important. And when you think about how Agentic is entering into the space wargaming platforms, go stop by their booth and take a look. We're really interested in developing a relationship with Agentic builders and enablers.
Right.
So, Caitlin, next, when you think about what Tom and Deborah both said, and you think about the investments that you're making, what do you find actionable most often inside of early stage startups?
Yeah, it's a good question, and good morning. Thank you for all of you that came out. I know this is an early call time, so glad to see you all here. I think a good kind of framing for not only this question, but for the conversations we'll be having with the founders here is that I'm pretty unique on this stage in that I don't have a number of aerospace engineering degrees. I am an early stage investor. So my firm is also a generalist firm, which means that we are not focused exclusively on space or deep tech, which I think is a really, really, really unique moment in time. The fact that I am here on this panel with incredible people with these really incredible backgrounds and the founders that we have the privilege to meet, this means that we finally are within a time horizon that makes sense, meaning we are about to feel an explosion, as you two both used the words already, not just in technology, but in where that technology takes us. And so going off plan, if we make the assumption that launch is solved, when we think on a 10-year horizon, suddenly these investments are starting to make sense, which means that we are on the precipice of a massive paradigm shift. And so at 776, my firm, we think a lot about investing in the infrastructure for the inevitable, which means we believe that space exploration and taking our culture and our humanity and our technology off planet and expanding that is an incredibly important part of this next chapter for humanity. So we think about it in terms of investing in the infrastructure for the inevitable.
No, it's great. And as we seek to close that gap between the end of program dollars and the beginning of venture interest, it's critical that we find out what's actionable inside of those startups, and thank you for your part in that. So Mandy, I'm going to continue that question with you. When we think about closing the gap between the end of program dollars and the inception of early stage venture interest, how do you think about finding startups that represent things that are investable, things that are actionable, that guide your work with the early stage startups you guys are involved with?
Awesome. No, and thank you for the question. And again, thank you for being out here on an early Monday morning. This is awesome. Great question. And I think the only thing I'll take exception to in the earlier comments is the casual use of explosions with space things as a rocket and satellite person. That makes me a little nervous.
There's a lot of exploding going on out there.
But one thing in terms of how do we help bridge that gap, I really like your infrastructure for the inevitable nomenclature, because it really is, it's not about AI, it's about the mission, it's about the data, and it's about, okay, how do we implement the solutions that can help the decision support that needs to come from the data at the right time scale, right? So one thing that I really look at with the companies is like, okay, are they using the AI and the machine learning philosophies to really get at the heart of the problem that requires it? Space has always been at the leading edge of autonomy.
Right.
You live that, putting things on Mars routinely and making it look simple, right? So from the space perspective, we know how to handle that level of complexity. So now how do we help change what the mission can do to increase that the decision cycle, and how does AI really enable that?
You know, those are such interesting views on how we get early stage innovations into the American game. Too often we increment and index on mid-stage ventures, which allows us to lose important innovations and really, really strong founding teams. And so again, I'll exhort you as you listen today, how do you think about well-differentiated innovation and good, strong founding teams? With that, thank you judges for the super introduction. And I'm going to bring to the stage our very first presenting company. I'd like to welcome to the stage David Braithwaite with PlLace Labs. PlLace Labs is bringing AI to space to enable ultra-fast insights through multimodal sensing, edge computing in orbit. David, the stage is yours.
Thank you.
Sure.
Good morning. My name is Dave Braithwaite. I'm the Chief Federal Strategy Officer for PlLace Labs, where we bring you near real-time insights from space. The problem we're seeing today is that satellite imagery has to be downloaded, processed, and analyzed before you can understand what you've collected and if it's of any use to anybody, like a decision maker. When you consider that a single satellite image is in hundreds of megabytes, if not a gigabyte in size, the time it takes to download all the images a single satellite's collected, it's time consuming. And with our current communication processes, it's also expensive because of the amount of bandwidth required to do it. The result, a slow and expensive process that induces data latency for any kind of usable data for a decision maker. So whether you're looking for wildfire detection, illicit maritime activity, checking on the status of a power supply plant, or even supporting military operations, data has a half-life, and timing is everything. Our solution to this data latency in communication transport is something we call OrbitFi. OrbitFi solves the data download problem by going out and analyzing and compressing satellite imagery data directly in the satellite as it's collected. Our technique is actually able to reduce downlink by 98% and enabling people to get their insights from satellite imagery in as little as 7 minutes. The way it works, the customer comes and sends us an insight request. We work with one of our satellite operators and they go out and collect the image. OrbitFi then processes the images directly in the satellite, analyzes and produces a report. It takes all this information, compiles it into one tight information file and transmits it via inter-satellite link relay to the ground. Using this process, we're able to take those insights that you normally wouldn't find out for a few hours and days with our current method and cutting it down to just a few minutes. Our team is headed by our CEO, Bosco Lai, and CTO, Gaurav Bajaj, who together have over 45 years of experience in software engineering, business development, and production. Together, they've amassed a team with over 180 years of experience across business, technology, and defense. Currently, we're residing on 3 satellites with Sidus, D-Orbit, and Loft. All 3 have done successful in-orbit demonstrations. We've also been validated by the Department of Defense with the U.S. Air Force, recognizing the need for something like OrbitFi by awarding us more than $4 million in contracts to further enhance OrbitFi's capabilities. As part of our business model, we partner with satellite operators to host our software on their satellites. The more satellites we operate on, the more insights we can develop. What you see on the screen is our predictions over the next 5 years and who we're going to partner with and the amount of revenue we can generate with that partnership. We generate revenue one of 2 ways. The first way is to go out and do a subscription based with the users so they will get a certain number of insights over a period of time, over a period of month. The other one is on-demand insights for things like disaster relief or those events that happen in emergency when you don't see it happening and you need the information right away. Currently, we're in a $3 million fundraise at this time. With that fundraise, we're seeking to take OrbitFi and move it to technical readiness level 9, making it fully operational. We're going to expand hiring into getting more software engineers and more space operations expertise as we seek to take OrbitFi into doing the space situation awareness game. And finally, we're also going to go and seek to get more capacity on satellite providers so we can work towards getting our goal of generating $10 million in revenue by the year 2027. Wrong button. My name is Dave Braithwaite, and thank you for your time.
over to you.
I'll give it a first try. Great pitch. Thank you very much. You know, a important problem, especially now with so much data in space, and trying to get it down to the users, whether it be the warfighter, whether it be a scientist in the room, as fast as possible. What do you see? What do you see as your first real MVP, a real product? And how long in the future do you see it out there that you're going to have something that we'll call it operational at the first level? What, if not specifically the company, but which field of folks are going to be using your product first?
Yes, sir. So we're actually expecting to get online here in the next couple months with Sidus. We're not dropping names of companies, but we're just waiting for some stuff to happen on Orbit. It's already up there ready to go online for the maritime case studies. However, we also see, for your other question about who's the main user, it's mostly going to be Department of Defense for the near and foreseeable future that we can see. Because the Department of Defense, what's unique is we have that capability to support some of their biggest problem sets, such as strategic indications and warning. So understanding those problem sets that actually affect the national security and the posture of the country. Also, the military is very big on providing support to disaster response, if you guys aren't familiar with that. So that's another big thing. And then also we've had some with new missions with the Homeland on the southwest border, our ability to give them real-time tipping and queuing of either narcotics trafficking activity in the Gulf or seeing traffic moving across from the southern border operations. So for the near foreseeable future, it's going to be the Department of Defense. It's going to be our primary customer.
So maybe can you talk, I'll just say thank you very much, appreciated, really enjoyed your pitch. A couple questions maybe building on Tom's question. So it's really important that you have partners, as you talked about, and your revenue model is all about the subscription. So can you talk a little bit about your assumptions, sort of like what's your min viable product in terms of number of partners needed to sort of start to build up and get that revenue?
Yes, man, I understand the question. It's slightly complicated when it comes to satellite operations, your imaging. Primarily, we're looking at a minimum. We would like to get at least one revisit a day over a certain location on the planet. But for that, we need about 6 satellite providers to make that happen, depending on the northern latitudes, which is where primarily most of the security concerns are for the Department of Defense, because that's who we're trying to market first. However, what we want to do is get down to like a 3 or 4 day revisit rate over target, so we're looking at about 12 to 15 satellite providers to make that happen. And of course, there's other factors you got to calculate in there, such as the resolution of the sensor and things like that about does it have the right resolution to detect the right thing. So we're looking at 12 to 15 providers, usually about 2 meters resolution or less to help us with solving that problem.
Thank you.
Yes, ma'am.
I'm deciding which way to take this one. So we're talking a lot about your customers and your revenue, and who your potential partners might be when you're first starting up here. I think I want to ask a little bit about moat, though. So how do you intend on getting these folks to trust you with their most critical data? So I'm
sorry, ma'am.
assuming
What was the word you're saying? Modes?
Your moat. So like why would I trust you? So I'm the DoD or DOW or whatever we're calling them these days. Why would I trust you with my most important information?
Well, being that I was a 24-year military intelligence officer, I kind of have a little bit of insight about what it takes to navigate that terrain quite well. As a matter of fact, I'll probably play a little bit more inside baseball than I should with my buddies who are all skiing this coming winter. But I believe our company, number one, not outside of just me, but our software engineers and our GNS specialists, they also have understanding of working with the government with this kind of data, just in imagery, but also we're going out multimodal, because we're not just looking at just imagery, because that's just step one. Step two is going out to other modalities like RF, radio frequencies, SAR imaging, anything we can do to try and basically make the decision-making process go faster is what we're trying to aim for. And by that, we see doing that multimodal process. In my experience in the military operations, I understand exactly what that has to look like, what the decision is, and how the risk needs to be mitigated by having that specific data that answers that specific question. So when I go and talk to them, it's very easy for me to sit there and say, hey, I understand where you're coming from, I understand what you need, and I understand how to get us there and what we need to do. And it translates very easily.
Helpful, thank you.
Yes, ma'am.
So building on the same theme, but from the systems engineering perspective, how do you control kind of the end-to-end latency of the solution to the decision maker when the product that you're really the brain of the decision, not the actual hardware solution? But then the other flip side is verticality of, you mentioned the other modalities. How much sensor knowledge do you need to have for this to work? Basically, the question then is, how ubiquitous can this be that your solution, your Orbit5 solution, can go to all of the different EO providers?
Yes, ma'am. So, to make sure your question, you want to know how we make sure that we can get the software on there and how we control the data flow out of the satellite and on there. So we have capacity sharing agreements with our service level agreements with the satellite operators to say they have a requirement after the image has been collected to make sure we get the data transmitted with their inter-satellite link relay over a certain period of time. Usually it's within like 2 or 3 minutes after it's been processed. And it only takes us about 2 minutes to process the data on the satellite. The long part, which is funny, the long pole in the tin is actually using the ISL piece because it's RF and it's a lower bandwidth, so we have to compress that data, which is why it's so neat that we can do it in 7 minutes. As far as knowing the different modalities, again, I'm kind of playing inside baseball in this because that's what I did for 24 years, is using different modalities to do different things. I've got SAR imaging experiences, as well as our GNSS experts. I have signals intelligence experience. I have all of it. So it's not enough. It's one of those things where it's enough knowledge to make us dangerous, but not really solve all the problems at once. But it makes it very easy for us to understand what we need to make things happen and how that data flows and how it needs to flow to make faster decisions, even down to ballistic missile defense.
How do your models learn? If there's a dynamic situation going on in a part of the world, how could your model from one collector take advantage of the next overhead pass?
So we actually manage that through on the ground. We have a ground-based system where we manage all the models and develop on the ground, and then they get uploaded to the satellite afterwards. So the software is completely uploadable. Like, the satellite doesn't have to take off with the software on there. We can just as easily load it up there with the Docker image, and then we update and maintain the models as needed. So if somebody says, hey, I need a new model for, I don't know, seeing where trucks are out in the open, we can go do that in a couple weeks and have it uploaded. And it's a very small model. It's about 1/5 the size of a normal ML model, AI ML model.
Who are your competitors?
Time.
Oh.
Yeah, don't worry about that.
Saved by the bell.
I wouldn't mind having an answer to that one.
David, you're on the griddle.
Oh, man. So close. I know there's a lot of people that say they can do it, and it's one of those situations. I know that I've seen what they can do, and I know the name's escaping me right now because I thought I was going to go off stage. But there is competition in this space. It's only a matter of time for that to happen, but that's actually kind of a good thing. It just makes us all better and get better at what we do. But I think that what's going to set us apart from everybody else is that most people are vertically aligned with that competition. They're not looking at where we're doing multimodal, going out and trying to make all the data communicate with each other. So we go out there, and because it's so easy for us to sit there and tailor our software to be installed on any satellite that's out there, and work with any modality, any satellite, any ways, and knowing who needs it. I mean, we've already got serious conversations, actually contracts signed up with support from European Command, Africa Command, and Special Ops Command for us to get this even further enhanced. So not just the Air Force, but also the combatant commands, the guys that actually use this data, are itching to get this thing in play right now.
Okay, thank you.
Yes, ma'am.
Very well done, David.
Thank you.
David Braithwaite with Little Place Labs. And next up, I'd like to bring out Magma Space and Alessandro Stabile. Magma Space has developed a platform offering an autonomy stack for precision control and movement that leverages the elimination of jitter. Ladies and gentlemen, Alessandro. Good luck, Alessandro.
Hi, I'm Alessandro, founder of Magma Space, and we are building the autonomy and precision platform for high-performance spacecraft. Satellite vibration is compromising missions, and the main culprit are ball bearings within reaction wheels that are present in every satellite. And they are the major cause of jitter that is compromising today's missions, from Earth observation, concealing details, from communication reducing data rates, to being one of the major obstacles for emerging space capabilities like quantum in space manufacturing, power beaming, and we estimate that more than $200 billion in untapped revenue is held back by instability. And instability is not just a mechanical issue, it's also affecting autonomy. Jitter pollutes data, adding noise and uncertainty that ultimately breaks trust in autonomy, and that's where we come in. We are building a platform that leverages our maglev technology to truly achieve trusted autonomy. Our platform is built upon our groundbreaking development in magnetic levitation within reaction wheels and isolation platform. We don't mask or filter vibration. We remove vibration at its source. And we've collected at NASA, we already demonstrated that we achieve more than 20 times better stability than whatever is available today on the market. And this level of stability is critical for the AI layer because you need clean, jitter-free data to really reliably perform stuff like health monitoring, adaptive control, and autonomous maneuvers. And so our goal is to really build our primary platform to unlock missions that are today extremely challenging, if not impossible. And we have the right team to do so. I have more than 15 years of experience in magnetic levitation and space mechanisms, starting from my PhD, and also my last name is Stabile, so stability really was my destiny and my calling. And my co-founder, Jordan, is also an aerospace engineer that brings experience from Boeing and Amazon and MBA from MIT. And we have an amazing array of advisors, people that really built from the ground up companies, hardware companies that exited, or people that have experienced the problem of satellite instability, and they want to help us fix this issue. So to date, we received strong support from the government, more than $5 million in non-dilutive grants, and we've just been selected for a $2 million TACFI. We have 2 tech demos going up in 2026. We're excited about it, paid by the government. And we have more than 14 LOIs from prime, medium, small companies that are worth more than $60 million in annual revenue. And so our roadmap is divided into 3 phases. They also correspond to 3 different revenue streams. First, we tackle the immediate need, which is the satellite stability, through our maglev technologies that is drop-in. It can be added to any satellite that's being built starting from 2026. Our AI control stack that is being currently developed with the Space Force is going to be sold through a subscription model for satellites that are already in orbit or are being built starting from 27. And ultimately, our AI precision platform is going to create a new paradigm on satellite performance that can really unlock missions that today are not even possible. So we are currently fundraising a seed round that are going to be matched by TACFI. This funding will help us bring the first product to market, magnetic reaction wheel, and starting generating revenue. And so if anyone in the audience is interested in learning more, help us bring this autonomy and precision platform to reality and unleash the next generation of space application, please reach out. So thank you.
Thank you. I want to ask you a little bit more about what's happening in the AI stack. Could you talk a little bit more
Absolutely.
about what you're going to be doing there? I think you said you were doing that in development with the Air Force.
Correct.
Yeah.
So we have 2 developments at the moment. One is about data fusion using genetic AI, genetic algorithm, so to infuse the data, and really is critical to improve pointing accuracy, because by fusing data together, you can improve pointing knowledge and pointing accuracy. And then we're doing also predictive maintenance and predictive failure. So using neural network to detect if a failure is about to happen and how to deal with potential degradation of components. So this is really critical, because when you buy a component off the shelf, you see a data sheet, but you don't know exactly if that component really behaves as expected. And so our algorithm will constantly monitor components and make sure that everything is working nominally. And if something's about to degrade or break, we will be able to redirect or readjust the way we use certain component. And ultimately, we want to use federated learning to, at a constellation level, having satellites that can learn from each other and share information, so the whole constellation will improve the way they operate with each other.
Thank you.
How many employees do you have right now?
We are 5 full-time employees. We have partnership with MIT Lincoln Lab, with Moog. We have veterans that are contractor for us. The shutdown is affecting us a little bit,
Right.
but we are growing our team. We have 2 more people that are about to join the team, but yes, we are a 5-person team in a WeWork office. It looks like a lab, university lab,
Yeah.
and we are building stuff in there, they don't like it, but we don't care. And we're trying to really make the most of a small environment. It's almost like a garage in Silicon Valley.
Right.
That's what we're going for. But of course, as we grow, we will find the proper facility.
Of course. And so the assumption is that part of this capital will be used to continue to grow your team, right?
Absolutely. And also, the advantage of having the TACFI, the government is going to pay for the development of the tech. Our funding that we're raising right now is to help us on the business development and commercialization, hiring business development people that can really continue to explore customers and make sure that we are building something that is needed.
Great. And so, sorry, it's a multi-layered question. I just want to make sure I was getting to the right assumptions here. So your platform is tackling both autonomy and hardware.
Correct.
And so how, as you're thinking about your future team build out, how do you think about how your team might be handling that duality effectively? So to have both of those in-house with a small team is no small feat. So how are you thinking about that?
Yeah, I mean, of course, the two are really intertwined, right? Because as I said, the hardware piece is what allows us to really detect the smallest variations, right? So we need to constantly talk the AI person with their mechanical engineer to really make sure that whatever we are building is producing the noise is so low that we can detect any type of variation in the system. So the two are working really closely together. And yeah, so there's going to be, as we grow, more of a AI team and then more of a structural and mechanical team. But the idea would be to have them really close together.
Thank you.
Pulling the same thread a little bit in terms of the feedback loop here, but a layer larger. So when you have this knowledge, because you got the hardware and the AI working together, how do you envision, or how would you like to then work with the bus providers, the larger partners, and even the mission architects in terms of how can they really rethink what is physically possible with these platforms and completely redesign, like, what is the mission you can perform at the end of the day?
It's a great question. And so at the moment, at the beginning, of course, we'll be selling into primes or satellite manufacturers, and we need to educate them, of course, what are the possibilities, because they're not even thinking about what can be done. But ultimately, our goal is, when we build a full platform, is to deliver full mission around our platform. So we want to actually sell the full like a satellite with our platform built into it. And when it comes to like how do we convince primes, it's interesting because when I started with NASA funding, the idea is NASA, when it comes to really high performance satellites, jitter is the first thing you need to build for, and then everything else trickle down. And so we need to kind of like use the same mentality. Like if you want to build for power beaming, laser comm or something that really needs the platform to be extremely stable, jitter needs to be the first thing you need to address, and everything else needs to be built around it. So hopefully we will help them by having a platform that already eliminates the jitter to begin with, and so the whole design and development is going to be easier from their perspective.
Thank you.
Great talk, Alessandro. Talk a little bit about, so at the end of the day, when this works, you're going to have a product, right? It's got to be a high-performance, precision product that's going to last for, maybe a decade, 15 years on a spacecraft. Talk about now manufacturing, production, right? So when we buy reaction wheels today, it's like, right, you dig really deep into the ball bearings and the shape of the ball bearings. It's a really technical field. So what are you thinking about production here when you go from 5 people to, having this really intense, high-performance production environment?
Absolutely. So at the beginning, we will subcontract some of our production, and we will do the final integration and testing. Of course, as we grow production to reduce the margin, to increase the margin, we will bring the production in-house, especially for the manufacturing of the most components. Magnets are still one of the things that we need to make sure that the U.S. brings more manufacturing in the U.S. and Europe, we will leverage them more than China. But yes, absolutely. At the beginning, our production is going to be for 20 to 30 sets of wheels, so satellites, 20, 30 sets, 20 satellites. But as we grow, the goal will be to meet the hundreds of satellites, because we see that especially for laser communication, the data rates today are a % of what you can really push through the laser comm. So we want to be there when we will have this big jump into the next level of data rates.
The government doesn't buy reaction wheels.
Correct.
They buy missions.
Correct.
So what are some of your early go-to-market strategies, or where are you finding traction, or what's a door you would love to see get broken down to help foster companies like yours?
It's a great question. So we need to do a triangulation, right? We need to convince the government that what we have is unique, and they need to add the requirements so that primes needs to buy us, right? So we need to do this constant, triangulation within all these companies. So we're talking to major primes. Lockheed is one partner. Moog is another one. Maxar, of course, is split in different companies, but like we're still talking to them. And so the idea would be, as the government tries to, with the tranches, right, the Space Development Agency tranches, more and more requirements will be related to what we're doing. And so the goal will be to help them push the requirements to the primes or the satellite manufacturer, and then we are going to be the critical component on those platforms.
And with that, judges, we're at time. Any last questions? Anybody have any last thoughts? You're getting off easy.
It's really bright in here, yeah.
Alessandro, thank you so much.
Thank you.
Thank you, judges. Next up, ladies and gentlemen, I want to invite Aaron Borger with Orbital Robotics to the stage. Orbital Robotics builds AI-controlled robotic arms and guidance, navigation, and control software for spacecraft. Ladies and gentlemen, welcome Aaron.
Hey everyone, I'm Aaron Borger, founder and CEO of Orbital Robotics, and we are building AI-first robots for space. Many of these satellites in orbit still use outdated software that is insufficient for high-value operations like autonomous docking, repairing, refueling, removing space debris, even assembling space stations in orbit. So we're fixing this. Additionally, with the increase in launch vehicles coming online, the number of satellites in orbit will increase exponentially. Each of these require end-of-life procedures, usually moving to a graveyard orbit or deorbiting. But our customers have indicated they would rather extend the life of their satellites rather than doing that. So our GEO customers have indicated they would pay $30 million for a life extension, and LEO customers want to be able to maneuver without regret. So we're providing robotic arm hardware, as well as our AI autonomous software to do this. Our primary innovation lies in our deep reinforcement learning AI engine that allows for accounting for dynamic coupling while we can capture objects in orbit, as well as manipulating spacecraft. But we're using AI and software in space, which requires verification. Our verification approach includes Lyapunov stability, where we calculate a cost at each time step and verify that it is minimized over time, verifying that our system produces our desired behavior. The use of reinforcement learning also allows us to collect data on orbit, continue to learn from that data, and further improve our moat. Additionally, we use vision-based navigation that allows us to track spacecraft and spacecraft components without even training on them. Our team consists of myself. I previously was at Blue Origin, where I was the lead software engineer for the BE-7 lunar lander engine, and also later worked on a PhD with a professor who worked on the Canada arm focused on satellite servicing with AI-powered robots. We have Doug Cole as our COO, who worked on 100 space shuttle missions, and also at Blue Origin worked on Blue Ring, Orbital Reef, and the New Glenn second stage. We have Riley as our hardware engineer. Riley and I worked together during undergrad to launch 6 AI-controlled robotic arms to space for NASA. And we have Sohail as our software engineer. Sohail and I worked together at Blue Origin to develop AI and machine learning algorithms to predict the health of rocket engine. On our advisory board, we have Dr. Gordon Rossler, who is a program manager at DARPA for the Robotic Servicing of Geosynchronous Satellites program. Chris Imbrowski, one of the first commercial astronauts. Taylor Banks is our financial advisor, who also has advised for Relativity and Stoke. And Colonel Eric Feltz, who was a director at AFRL. In our startup journey, we are just finishing our pre-seed round. We were aiming to raise $500,000, but are oversubscribed and will be close to $1 million. Our revenue projection, we're looking at $1 million next year for 3 demos. That includes demonstrating that we can capture another satellite in orbit, maneuver around a RSO, resident space object, and inspect it, and assemble a space station. In 2027, we're looking at $8 million once we put our robotic arms and AI software into production, and then $108 million by 2030 once we have our robotic arms. We're looking at 30 robotic arms and AI software that we need to deliver per year according to our LOIs. And then at that point, we'll also have our satellites online so we can service our own. These will all come from the robotic arm sales, our AI autonomy sales, and then the satellite servicing. Our AI autonomy robots are the solution to building a flourishing economy on orbit, on the moon, and beyond. Thank you.
So again, you're a combined hardware and AI company.
Correct.
You talked about robotic arms and then the AI autonomy piece and the satellite servicing elements. Can you talk about that build out and how you're going to, approach that? Is it starting with the robotic arm? Maybe just talk about that and what your assumptions are.
Yeah. So we're
in terms of your revenue streams there.
Yeah. We're starting by just selling our robotic arms and our autonomous software to other customers who already have their own satellites, mostly because it's going to be very costly if we try to develop our own satellite, and that's going to take a lot of time. So we're relying on some of our partners and customers to develop with them, and then do our demonstrations on orbit with them as we develop our robotic arm hardware and our software. And then later we'll move to developing our own spacecraft, so we can use some of that revenue to actually use for development.
So the world of robotics now, is really exploding, humanoid robotics and so on. There's a blend from the historic, right, like meaning today and yesterday, of software stacks that were modular and even scripted, to today and tomorrow about the AI is you're just going to put everything into a model and train it and forget about all the software in between, right? The model takes care of it. So as you're starting a company now, kind of where you're at in the spectrum, and how do you think you're going to be able to navigate that in a time frame where what's real coming from the AI could actually fit into your product base according to your timeline, and what do you have to go from the old days and kind of pull into it?
Exactly, yeah. I think one of the things that we're seeing is with the humanoid robots, they want to take end-to-end neural networks. So they directly take camera, vision, sensor data, and then input that into the neural network and output actions. We aren't doing that because it's hard to verify. So our approach is more, you take position, orientation, velocity, things like that, input that to the neural network, and then do very small actions. So each neural network is trained in maybe attitude control or translation control, and we can verify each of those pieces. So it's a combination of the new, but also the old, so we can actually verify it.
And do you see a timeline, a roadmap where you know how to pull the pieces in and be confident, that piece is going to work? Talk a little bit about your validation, basically.
Yeah. So we've been testing in simulation right now. A lot of that is through NVIDIA Isaac Sim or our own customized simulations. And so we verified that we can actually do attitude control, translation control. We're starting to get to the point where you can control the robotic arms and grab other objects. And we've already demonstrated that we can control the robotic arms, account for dynamic coupling. So when you move the robotic arms, the spacecraft moves in response to that. We can overcome that. After we do that in simulation, we're now moving to manufacturing our own robotic arms. So that's going to be over the next couple of months. And then we have launches scheduled with our partners next year. So the first one in next summer, where our software will control a spacecraft to do inspection, and that'll be using the AI software. And then the next one will be in October, where we control a robotic arm to actually capture that first spacecraft.
That was actually, you started down a path I wanted to ask about in terms of test strategy. So what is your test strategy for your on-orbit demos, and why?
Yeah, a part of that is we have a hardware-in-the-loop emulator on the ground, so we can get a whole bunch of reps in and iterate while we're on the ground before sending to orbit. So we have one robotic arm that controls, you could say, our client or target satellite that we want to capture, and the robotic arm moves it around to emulate the relative dynamics in orbit. So then we use our spacecraft that has the robotic arms on it that goes and captures that, and if there's contact, we can also measure that with a force torque sensor and move the spacecraft into response to that.
So this servicing area and this whole area has been a little bit challenging a bit with chicken and egg in terms of, government customer there and who's putting money in. So can you talk about your approach to that, given that's such a challenging area?
Yeah, a lot of our approach is we have already talked to some of the satellite operator customers, and they said they really want the tech, but they need to see it work first. So there is that chicken and egg problem where it's hard to get the money to deliver something into orbit because it's so expensive, and it's hard to prove that you have revenue because satellite operators want to see it work first. So our approach is, with our pre-seed round, we basically have gone to former Blue Origin, former SpaceX engineers and said, hey, this is what we're trying to do. It's a little risky because we know we need to make our demonstrations work, but once we work, we've already talked to satellite operators and we know they need it.
Thank you.
Aaron, I was excited to see your company on our lineup as we were all preparing, because this is an area that I actually have deep expertise in because I worked at Pixar on the film WALL-E. So I was really excited to see robots. I obviously joke, but I was excited because I think that there are so many different use cases that this technology can ostensibly solve. I want to take this last minute here to talk a little bit about talent. So you talked about your network and being able to go and talk to folks that are in your network that are working on really, really important missions that are very near term, right? As you're thinking about building out your team, when you fantasize about, this check that's going to come in, congrats on your new round, where do you think, so you have a really strong team already, but where is the best talent to help you fulfill your potential right now? If you were to go out and have your dream pick, don't name names, you can tell me later, but where are they living? Where are you going to be sourcing?
For the most part, we're based out of Seattle, and that's partially because a good portion of these satellites going into orbit right now are coming out of Seattle. So there's a huge talent base. Part of that's coming from Blue Origin, since they moved all their software engineers to Kent, Washington. So we're based out of the Seattle area for that reason. But then also SpaceX has their Starlink out of Redmond, Washington. So we get all the talent from there. But overall, I'd say a little bit of combination of Blue Origin engineers, SpaceX engineers, and then a lot of the research. There's like University of Washington, all the other universities that are coming out and doing research on the satellite servicing are great. So we're combining the research academics with the commercial industry expertise.
Excellent, thank you.
What help do you need? What space domain awareness help do you need to make sure that when you're testing and demoing this, it's working as intended and you get the right data?
A lot of it is, well, first we need more connections, and the military, national security realm, and so that's what we're working on now, is just reaching out, networking more, and that will allow us more opportunities to demonstrate, communicate with, and partner with some of the other companies as well as the government side. So that's what we're looking for right now.
Aaron, thank you so much. It's a great presentation. Ladies and gentlemen, a hand for Aaron Borger. Judges, great job. And so our final presenter is Robbie Robertson from Sidaro. Sidaro delivers mission simulation at scale to power the future of aerospace and defense. Robbie, welcome to the stage, and good luck to you.
Okay, so thank you. Sidaro, we deliver mission simulation at scale for the space and defense market. And what we're disrupting is really the previous generation of simulation tools in this market that can't handle the integrated, distributed, and automated nature of the future systems that will define advantage in modern warfare. So our product is an enterprise software platform that can simulate hundreds or thousands of complex vehicles across all the related physics and do that faster than real time and in an agile framework. The underlying core technology is parallel distributed simulation tech that at runtime, when you submit a job to be simulated, it actually generates the multi-physics simulation engines and optimizes them to load balance across cloud infrastructure. So this fundamentally different approach and that differentiated tech allows us to deliver simulations that are 100x scale and deliver them 10 times faster than is possible with alternative solutions in the market. So this simulation playback in the Sidaro platform, and hopefully it kicks off here, covers a submarine-launched ballistic missile threat from the Arctic targeting New York City. So a salvo of SLBMs targeting New York City. And the flight time, see if I can get that playing, the flight time is is 15 minutes. So in 15 minutes, an integrated network of systems across all domains, air, sea, land, space, automated processes, manual processes, all have to work together to close that kill web and intercept those 10 SLBMs. If any of those individual nodes in the kill web fail to do their job, there are obviously disastrous and substantial consequences. And those things can happen. So what simulation does is it allows us to find those gaps, find the gaps that we need to close and address those risks, and optimize and decide and automate and train AI eventually to cover as much of this as possible. But a lot of people can provide a view like that, and you've probably seen them before. What makes it Aero different? And the answer is scale. So with our platform, every node in that kill web can be simulated at full fidelity, all the subsystems, the components, and the associated physics. And US advantage, general advantage superiority in warfighting today is primarily driven by information superiority. What we can do with this capability, more holistic warfighting virtualization, is drive agility, drive effectiveness, and also connect solutions from the market directly to warfighter needs. And that has the potential to really disrupt aerospace and defense broadly and ensure continued superiority and deterrence of conflict through US superiority in decision making and innovation. And we're doing that, we're proving that today. We've flown tactical edge AI for the US Space Force. Earlier this year, we're flying it again twice in the next year. We're delivering an LLM integrated tactical decision support platform that virtualizes warfighting across domains and then provides that LLM interface across the enterprise to help operators make decisions. And we're delivering a hybrid space architecture digital twin that'll be used for AI training and AI-driven mission planning. So team, myself and my two co-founders, Dan and Bass, we came here from startups, from contractors, from government labs, and where we built space hardware, simulated space vehicles, and built deep tech software. And now we have a team of about 35 with really an ideal and incredible mix of top-tier talent in physics and sim software, and on the growth side, connecting that to government missions.
Aaron, sorry.
Yep.
Robbie, thank you so much. 4 minutes is up. We're going to turn it over to the judges. He's all yours.
All right, great. Thank you.
Talk about your business plan here. Is this software as a service? Are you going to operate it? You're going to you're going to sell it to partners? What's the plan? Maybe it's on your last slide there to really get it out the door.
No, this is good. It's a good place to land. So we've been at it 6 years. We had a lot of SBR support early on and started selling a product about 1.5 years in, and then have transitioned to, away from SBRs over the Valley of Death as of like 3 years ago. And the business model is software as a service, so annual recurring licensing of the platform, but unlimited headcount. Because a lot of the value in a digital capability like this is the connectivity to users. And then associated with the platform licensing, we provide implementation services. So we have those forward deployed engineers that are typically working on site with us that we have the facility clearance, TSSCI, we have the contract vehicle, $20 million IDIQ, and we can implement the platform. So basically functions like a cloud OS because we can build an app on top of whatever that differentiated SIM capability to be a wargaming tool or be the operational decision support tool or the AI training tool like the examples that I mentioned. So it's implementation services, commercial, as a vendor, if possible, as a direct cost on the government contract, pre-priced packages, and then the platform licensing.
Can you speak a little bit about the buildup of your models and the validation? I think you mentioned sort of you're differentiating, being able to have different levels and detailed models at kind of various levels there. Can you talk about that validation process and sort of the way you're approaching that?
Yeah, absolutely. So the simulation libraries are actually not formally licensed as part of the platform, which gives us a lot of flexibility in export and transitioning that large-scale sim tech to pure commercial markets in the future. But in the libraries, as you suggested, are physics engines that we've developed internally. And we build them in the framework that was developed alongside the core tech. It's really a full stack solution. There's that sim service. There's a configuration managed, modern software-based system for managing all the modeling content and the sim content. And when we build those component physics-based simulators, we build unit tests, and we have a modern, a DevOps pipeline and DevSecOps pipeline to make sure that all our ATOs are maintained and documented automatically, and that also, more to your point, that the physics meet certain basic requirements. Though, especially when you get to the scale of integrated simulation that we're talking about, and the value is that it's agile and it's adaptable, so you change what you're asking the platform, you change your system design. The sim's different now. It's going to perform differently. The quantitative metrics for traditional VV&A are going to change. But the advantage is also we're cloud native, so not only can we run the 1,000 core sim, but we can run it 1,000 times and build as part of the pipeline for a particular application the uncertainty analysis and things like that quantitatively into the solution. So we meet basic stuff, and then we wait for a customer to tell us, the sim, the output of this overall workflow needs to be accurate to this level, and then we can monitor it, and if it fails that, then we can charge implementation to improve a simulator or fold in a third party. The architecture naturally lends itself to any existing capability to be put in the loop and co-simulated in the cluster or remotely, which is essential in this market because everybody has a tool. They trust the tools. Tools are important.
Thank you.
Do you have any commercial business case that you're looking to pursue?
So today, the focus is defense and intel, where we found success, where we've been able to scale the business and be a profitable 35-person business with only 2.6 million dilutive capital in. Now, over the life of the company, like the first 5 years, really, we were, doing dual use and more creating the platform for that, creating the associated business model for that, and then all that testing really led us to focus in on where we can scale and make the biggest impact today, which is the DoD and IC market. That said, the underlying tech has been set aside from a data rights perspective as pure commercial. When we do a SIBR, when we implement with a customer and they keep some data rights, that's just content to the platform. And so we don't have to be sensitive about it, and we'll retain that, cloud scalable distributed sim tech into a commercial market in the future, or whoever owns it at that point. So,
how are you thinking about security? So this seems to me like this could potentially be a very ripe soft spot for bad actors to kind of come in the back door, especially if you're on the cloud.
Yeah.
So how are you investing in security?
Absolutely, and you can't be important in this market without you want that to be the case almost. But security has been a big part of our process and business, for the 4 years that we've been selling the product through OTAs and more formal programs. We've got accredited instances. We're supporting mission ops for an SDA, 2 constellations in secret level mission ops. We can deploy on-prem, Google Cloud, AWS, Azure. We've deployed in ATO environments or sandboxes for all of those. And our CTO knows more than he would like to about IT and cybersecurity now. We've also just hired and we've made investments in a team that's built this into our pipeline. So all the docs, all the scans are auto-generated through the pipeline to the max extent possible. And we can clear an ATO now, at least the examples we have, IL 5, 6, in 2 weeks, 2 FTE weeks. Not in real time, in our FTE time, maybe 6 months to a year in government dependencies. But.
Awesome, thank you.
How deep do you go into the physics-based simulation? Because the example you showed has orbitology and missile tracks, but are you getting to the sensors, the spacecraft themselves? How deep do you go?
Yeah, we do. The libraries that we have built in today, like that we deliver with the platform for free, have an extremely high fidelity space vehicle simulation. That's a lot of where I came from, and it's better than anything else we've seen, certainly commercially available, and we can deliver it fast. So it's telemetry level. It's voltages, currents, integrated power network, ACS, reaction wheel speed, fuel level, We have robotic manipulator libraries, docking ports. We can dock and couple the physics for integrated systems. A lot of fidelity on the space side, and then increasing fidelity for missiles and aircraft and other systems. But a lot of it's applicable. You know, you do SATCOM, you can put the same physics on the ground and the same logic and networks and stuff like that.
Robbie, thank you so much. You know, it's so terrible. They never see me standing behind them. They don't know that I'm lurking. That was an excellent presentation. Ladies and gentlemen, can we have a round of applause for all of our pitching companies? These people work so hard on their pitches to get it down to a 4-minute pitch and to talk about their innovations and their teams and their commercial prospects. It's not easy. Try it sometime. Judges, excellent questions. We're so grateful for your time and for your efforts because it helps uncover the story of what innovations, what business models, and what it looks like to move forward in an America that has a critical need for early stage innovations. So with that, we're going to have the judges follow me to the green room for deliberations. You can find out who won if you come back at 11:50. We'll look forward to seeing you then, and thank you again for your time and attention.